Welcome back to Aurora Tech channel. Last year, I reviewed the Mingda Magician X, which is a pretty nice mid-range 3D printer that costs just around $300. Today, I will review the big brother of the Magician series, the Magician Pro. This is a very large printer, and if you consider the Ender 3 to be a standard size printer and the CR10 to be a large size, then this Magician Pro would be an extra large size printer. The print volume is 400 by 400 by 400 millimeters, which is about 78% larger than the CR10 series. It comes with pretty good hardware, and it has all the features you can expect from a new generation 3D printer, including a dual Z-axis, a BMG-style direct drive extruder, and a V6-style hotend. There's also a strain gauge auto bed leveling sensor, a 32-bit board with a faster Cortex M4 processor, silent stepper drivers on all axes, a color touch screen, belt tensioners, and a filament sensor. The hardware is pretty similar to the Magician X, as it is just a pumped-up version. It also came with two extra aluminum extrusions to support the 400mm tall gantry and a one-piece metal base to make the frame more sturdy. I would like to thank Mingda for sending me this machine to review, and with that, let's get started. The assembly is super easy. We have the base, the gantry, the filament holder, and some tools. Let's start by moving the 20 by 20 extrusions out of the way, and then place the gantry on top of the base. Secure the gantry with 3 screws on each side. Next, move the 20 by 20 extrusions back up and secure them to the gantry using 1 screw on either side. Then, install the filament holder by just sliding it on either side of the gantry slots. Now, let's connect some cables, starting with the Z-stepper motor cable. Connect the heated bed cable, the second Z-stepper motor cable, Z-limit switch, and this integrated ribbon cable that helps to keep the cables more organized. Finally, connect the power cord and turn on the printer and remove the protective plastic surface on the print bed. Start with auto home to make sure that everything is working, and then wait for the bed to heat up to do auto bed leveling. Feed in some filament, which in my case is sample white PLA that came with the printer. I will just print a series of lines to set the Z offset and use the baby step menu to move the nozzle up and down to make the filament stick properly to the bed. 0.5 seems like a good distance, so we can now save the value. Once the Z offset value is correct, the rest of the lines stick to the bed perfectly. We can now start our test prints. Let's go to Cura and set up this printer. Select Add Printer, Non-Network Printer, Mingda, and we have the Magician Pro here. Just use the default settings of the printer profile. Let's take a look at the default print profile. The temperature for PLA is set to 190 degrees Celsius and 50 degrees Celsius. The retraction distance is 2 millimeters and the speed is 25 millimeters per second, which looks okay. Let's print a calibration cube using the sample white PLA. The print turned out pretty nice. The layers look good, the text is clear, and the dimensions are also accurate. Next, I will print a 3D benchy. The result seems okay, and though there is more stringing than I would prefer, the layers look fine, the cooling is good, and it is still a decent print. I will replace the sample PLA with some Overture PLA to reprint this benchy and see if we can get a better result. I think it looks much better, so I will just use some normal quality filament to continue the test. Seeing as this is a very big printer with a print volume of 400 by 400 by 400 millimeters, let's test out some bigger prints. I will start with this phone stabilizer that I designed in Fusion 360, which also has these cold shoes which are designed to be able to hold things like lights to help with filming. If I use 0.2 layer height, it's going to take almost 19 hours, so I will use 0.3 layer height instead, and it's going to save almost 5 hours. So, I will use some Creality white PLA and print at a 0.3mm layer height. This model is fully functional. Parts I printed previously fit perfectly, and the LED light fits as well. After this, I will print a gigantic 395mm tall trash can. If you print something at this size with a solid body and a standard 0.2 layer height, it's going to take 19 days. But for a trash can, we can use vase mode to just print the bottom and the wall, and it will still take 34 hours. But if we switch to a 0.8mm nozzle and print at a 0.6 layer height, it only takes 14 hours and 18 minutes. I will use Creality Blue PLA to print this model. However, near the end of the print, the filament ran out, and so I just randomly grabbed some Prusa Black Galaxy PLA to finish off the print. The trash can looks great. Generally, a bed slinger with a tall gantry will have more issues with tall models, so I used 2 extra binder clips to secure the bed. I will talk more about this later. The print time of 14 hours and 18 minutes is still fairly quick for such a large print. Using the same settings, I then printed a model of the Chrysler Building, which also stands at 395mm in height. This print took 8 hours to finish. The fine details don't look as good as they would have if we had printed at a 0.2mm layer height, but it finished much faster and still looks pretty cool from a farther distance. Let's go back to printing some smaller models with different filament. This time, using a 0.4 nozzle and a 0.3mm layer height, I will try printing this ABS towel hook. The first attempt was unsuccessful because of the small contact surface of the model, so the print did not stick well. However, when I applied some glue and tried the print again, it finished without any more issues. The small contact area now sticks pretty well to the print surface with glue. A 0.3mm layer height works just fine for functional parts. Next, I will use orange PETG to print this pen holder. Printing with PETG usually generates more stringing, but it was still easy to clean up on this model, and it wasn't too big of a problem. Finally, using black TPU filament, I will print this model of a doorstop. The print is very straightforward, and its end result is pretty good quality and is functional. Let's talk about the pros and cons of this printer, starting with the pros. 1. This printer is huge, but it is still very easy to assemble. You just need to put the gantry on top of the base and tighten the screws from the top instead of the bottom. The entire assembly should take less than 10 minutes. With the larger 400x400 print bed, I can actually print something like this phone stabilizer that I wanted to print a long time ago, but I could not do that with the rest of my printers. I also put the download link of this model in the video description. 2. The build is solid and the hardware is pretty high quality. The base has a one-piece metal plate at the bottom with 2 extra 20x20 aluminum extrusions, which makes this printer heavy and super sturdy. 3. The BMG clone extruder and the V6 style hotend work very well. I can easily switch to a standard V6 0.8mm nozzle and print at a normal 60mm per second with a 0.6mm layer height without any extrusion issues. 4. There's no more leveling spring under the print bed, and it just lets the auto bed leveling sensor do its job. 5. It has a wider x-axis, and instead of a 20x20 aluminum extrusion, it uses a 20x60 profile to provide better support. 6. The printer supports a full-size SD card and a USB drive, which is much better than just supporting a micro SD card. 7. The screen menu structure and button locations are reasonable. You can easily find what you need, and you can also customize the preheat constant on the screen, which is very handy. 8. The fine details on this printer are better than average. They use higher quality limit switches on the X and Y axis and an optical limit switch on the Z axis. Now for the cons. 1. The print bed is only secured by one clip at the front, and it uses force to push against the back to secure the bed. However, in my case, I can still move the print bed with my hands, which is going to affect the print quality, especially when the model is taller. But according to the picture on their website, there should be 3 clips instead of 1. So I'm not sure why my unit was missing 2 clips, but I just added 2 extra binder clips to secure the bed. It's not that big of a deal to me, but if someone did not realize this and just used 1 clip to secure the bed, that would become a problem when printing something tall. 2. It does not use the bed leveling sensor to home the Z-axis, and it uses the optical limit switch instead. So, the bed leveling sensor is just used to create a mesh, and the first layer accuracy still depends on the optical limit switch. As I expect that the bed leveling sensor should be more accurate than a limit switch, it would be better to remove the Z limit switch and just use the bed leveling sensor for Z homing. 3. The Z offset menu on the main screen is quite confusing. It won't move the nozzle up and down to let you set the Z offset like most other printers. It just lets you adjust the Z offset value, send an M851G code, and save it to the EEPROM. The way you set the Z offset is by starting a print and adjusting the baby steps in real time. I suggest that Mingda could redesign the Z offset menu. Once the user enters the menu, the printer should home itself, move the nozzle to the center of the bed, and go to the 0 position. Then, the user can use the up and down arrows to move the nozzle up and down to set the Z offset. In case fine-tuning is needed, the user can use the baby step menu while printing, which would be more reasonable. In conclusion, this printer is a very solid, large printer. You pay a similar price for a mid-range 300x300x400 printer, and you get all the same features, plus the 78% larger print volume. It prints very well after the print bed is secured by 2 extra binder clips, even for models that almost use up the maximum Z height. Normally, for a 400mm tall gantry printer, you would expect the top of the print to not look as good as the bottom, but for this printer, I cannot see a significant quality difference between the bottom and the top of the print. However, it may not be a good idea to have this as your only printer, as most people may be concerned that a larger heated bed will consume more power. For your reference, using this printer to print a PLA 3D Benchy with a 200°C nozzle and a 60°C print bed will consume 280 watt-hours, while a basic Ender 3 with a 235x235 print bed consumes just 204 watt-hours. So, this printer will consume around 38% more power. I would recommend this to be your second printer if you need to print something really big. Of course, if you're not living in California or New York City, where the electricity is super expensive and costs 45 cents per kilowatt, it may not be that big of a deal. For other states or countries where electricity costs just around 10 cents per kilowatt, you only pay a few more dollars every month, even if you are printing with PLA 24/7 non-stop. I put the link to this printer, as well as their Facebook support page, under the video description. That's it for this video. If you like this video, please do like and subscribe to my channel and press the bell icon to receive new video updates. I will see you next time.